Good day, G10. Welcome back to Mathematics 10A. I hope you've enjoyed the IS week and another week, which is a sort of academic break. One chapter has just unfolded, and in just a few days, you will be able to find out how well you did in the last quarter. Here we are again starting another quarter. I'm hoping you will learn and enjoy more as we discuss about polynomial functions, its factors and graph, and also a little of the equation of the circle. Starting with lesson number 9, we have the division of polynomials. On this lesson, you are to illustrate polynomial equations and functions. Also, you have to solve problems involving polynomials. And you are to perform division of polynomials using long and synthetic division. Take a few moments in dealing with this problem. This is an example of an application of polynomial functions. This lesson will also help us answer this question. How are polynomial functions related to other fields of study? How are these used in solving real-life problems and in decision making? So let us start first with differentiating polynomial equations from polynomial functions. A polynomial equation is an equation composed of polynomial expression. Polynomial equations in one variable of degree n is denoted by a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus a sub n minus 2 times x raised to n minus 2 plus up to a sub 1 x plus a sub 0 is equal to 0, wherein a sub n minus 1, up to a sub 0 are real numbers and n is a non-negative number. To simplify the definition, let us have this example. 2x squared minus x plus 5 is equal to 0. This is an example of a polynomial equation, wherein 2, negative 1, and 5 are numerical coefficients, while 2 is the degree of the polynomial. While for a polynomial function in one variable, specifically p of x, it is denoted as p of x is equal to a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus a sub n minus 2 times x raised to n minus 2 plus up to a sub 1x plus a sub 0, wherein again a sub n minus 1 up to a sub 0 are real numbers and n is a non-negative integer. Now for the examples, let us take these conditions for us to consider an expression to be a polynomial. First, the variable should not be under the radical sign. Second, the variable should not be in the denominator. Third, the variable should not have rational exponent. And 4, we have variable should not have negative exponents. And for the last, we have variable should not have the decimal exponent. An example of a polynomial function in standard form is given on the picture. We have p of x is equal to 5x raised to 4 minus 2x cubed plus x squared plus 1. The leading term of a polynomial function is the term of the polynomial which has the highest exponent. On this example, we have 5x raised to 4. The leading coefficient is the numerical coefficient of the leading term. In this example, we have 5. And for the constant term, that is the term which has no variable. A polynomial is said to be in standard form if its terms are arranged in descending order of power. Given on this table are examples of polynomial functions and its degree. The name of polynomial function is based on the degree of the polynomial. The next part of our discussion is regarding the division of polynomials. When a number is divided by another number, a quotient and a remainder result. To check if the quotient and the remainder is correct, we have to reverse the process. Find the product of the divisor and the quotient, and then add the remainder. This division algorithm applies both to numbers and to polynomials. An algorithm is a systematic procedure for doing a certain computation. The division algorithm in polynomial functions is given as follows. If p of x and d of x are polynomials and d of x is not equal to 0, then there exists a unique q of x and r of x such that p of x is equal to d of x times q of x plus r of x, or p of x divided by d of x is equal to q of x plus r of x over d of x, wherein p of x is the dividend, d of x is the divisor, q of x is the quotient, and r of x are the remainder, which are all polynomials. For example, we are to divide 3x cubed minus 2x squared minus 7x plus 4 by x minus 1. And then we have to write the answer using the division algorithm. Given here is p of x, which is equal to 3x cubed minus 2x squared minus 7x plus 4, and d of x, which is equal to x minus 1, which are the dividend and the divisor respectively. There are two methods that can be used in dividing polynomials, the long division and the synthetic division. For this problem, we will be using those two methods to solve for the quotient and the remainder. First, we will be using long division. This method is similar to the one used in dividing whole numbers. The steps in this method are as follows. First, rewrite the dividend and the divisor in standard form. Insert 0 as the coefficient of any missing term. Step 2. Divide the first term of the dividend by the first term of the divisor to get the first term of the quotient. Third, multiply every term of the divisor by the quotient that we have obtained. Step number 4, we have to subtract the product from the dividend and bring down the next term of the original dividend. The last step is we have to repeat the process starting with step 2 using the new dividend until the remainder is less than the degree of the divisor. Take note that we will only stop the process if we come up with a remainder wherein the degree is less than the degree of the divisor. So since we come up with negative 2 wherein the degree is 0, which is a lesser degree than x minus 1 because x minus 1 has a degree of 1. So therefore, we have now the quotient, which is 3x squared plus x minus 6, and the remainder, which is -2. So now let us check our answer using another method, the synthetic division. This method is used as a shortcut for dividing polynomials p of x by the form x minus c. Starting with the first step, we have write the value of c inside this symbol. Step 2. Write the coefficients of the dividend in descending order of powers. Insert 0 as the coefficient of any missing term. Third step, we have to bring down the leading coefficient to the third row. Step 4, we are to multiply the leading coefficient by c. c on our given is 1, and then write it on the second column on the second row. Step number 5, add the product from step 4, the second coefficient of the dividend. Step number 6, repeat the process until a product is added to the constant term of the dividend. Notice that we come up with the numbers 3, 1, -6, and -2. So the first three numbers are the numerical coefficient of our quotient, while the last digit is -2, wherein that is the remainder. Also observe that the quotient has the degree of 2 and the remainder has the degree of 0. Going back on our dividend, the degree of the dividend is 3 and the degree of the divisor is 1. Take note that the degree of the quotient will always be the degree of the dividend minus the degree of the divisor. So again, the degree of the dividend is 3 minus the degree of the divisor 1. That's 3 minus 1. We come up with the degree of the quotient, which is 2. So that's it. That is how we divide polynomials using long division and synthetic division. More examples will be tackled on our synchronous meeting, and for your questions, we will be entertaining that on that same day. Thank you and God bless G10.